All right, I think we are live.
Yeah.
So let me start. Hi everyone, welcome to today's session on how to manage time between teaching and research. This is Vijay Kumar, basically lecturer at SMIU right now doing PhD at Clarkson University. I welcome to our guest speaker, Professor Marko Budisic. I'm very thankful to Professor Marko for providing time to us in this busy schedule. So let me introduce Professor Marko. Professor Marko Budisic is an assistant professor at Department of Mathematics, Clarkson University. And before joining to Clarkson in 2016, he was Van Vleck visiting professor at University of Wisconsin Madison and also a postdoctoral researcher at University of California, Santa Barbara, where he also earned his PhD degree in mechanical engineering. His research interest lies in applied dynamical system with application to fluid mechanics, oceanography, biology. He has supervised 4 PhD students and number of undergraduate students. Welcome, sir, to our session. This will be very informal session, and we will be asking questions from you so that we can hear your perspective that how professors in US manage their time for teaching and research. The question could be very broad, so it's up to you how you answer to us. So let's start. So my first question will be why it is necessary to manage time between teaching and research. And this is really interesting question because I know that you are a very good teacher and you like to teach very nice courses, especially in maths and other departments. So what do you tell about this question? Thank you.
So thank you very much, Vijay, and thanks for the kind introduction. I hope to be a good teacher, but it's always a struggle. So yes, you're right. So I do have both teaching and research responsibilities, and I think what is important is that I think both of those have to be present if you're, at least from the perspective of US, right? Here at Clarkson, both for professors, but also for a lot of our graduate students, like Vijay as well, right? Is that your responsibilities are both to do research for me, in terms of just doing my job, right, and progressing in my career, and for graduate students to earn their PhD. So that research component has to be there. But then the teaching for faculty, we typically teach 2 courses in parallel every semester, with some without any teaching assistant supports, whereas the TAs usually teach 1 course at a time, but sometimes they will have multiple groups of students, right, that are within the same course. So if you're teaching calculus, you might be seeing several different groups of students. I think what is challenging in terms of research and teaching, why we even talk about this thing being a balance, is that in research, good stuff comes hard, and it's hard to see kind of very, very positive output, right, immediately. Even when you prove a theorem, and you still have to write it up as a paper, then you submit it, then you wait for peer reviews, then those peer reviews always find something negative, right? And by the time your paper gets published and you get some success out of it, you're alone in your room reading your email, right? There's nobody's tapping you on your back, right? So the motivation, the positive kind of feedback and the positive motivation for research always has to come internally. Whereas with teaching, if you're doing a good job, right, in the classroom, you can see that the students do appreciate you, they communicate with you. You can see within 1 semester how they're growing and how they're learning new things. So it is much easier to feel good after you do a good job. One day on one Thursday, you do a good job teaching, you feel good immediately. If you do a good job with research, it's questionable that you even notice it, right? Because you have moved your algorithm a little bit, you have moved your proof a little bit. There's never, okay, now I'm done with research. And so that's why I think it is a tendency to, I think for most of us who do enjoy teaching, right? A lot of us who go into research, whether it's in mathematics or other fields, we don't hate teaching, right? So we like sharing our knowledge, and we're excited about our knowledge, and so it is easy to kind of spend extra time on teaching and communicating with students because it also feels good immediately, and you feel like you're doing the job, right? Like the Latin word for doctor means the teacher, and so it is easy to kind of swing onto that teaching side. I think the danger with not spending a lot of time with research is then, even when you come back to it and you say, okay, let me now spend this entire semester just teaching, and then in the summer, I'm going to get back to doing research full time, for example, maybe when I have a little bit less teaching to do. It is hard to start where you left off, right? You have to spend another couple of weeks relearning the results, relearning the theorems, relearning the resources that you have let aside maybe only a couple of months ago or 3 months ago, figuring out where did I store that code. I remember I wrote it somewhere. Where in what folder are my images and things like that, right? And that eats up time, and it doesn't feel good again, right? It feels like, oh, I'm forgetful, I'm bad at this, right? And so letting research go cold is not only that you don't do new research, but you actually go steps back because you end up having to relearn the things that you have only discovered last time you were doing research. On the other hand, completely devoting yourself to research, right, and saying I don't care about teaching is in some sense disrespectful to the students, right? Because they expect that they will, for even if their tuition is not paid out of their own pockets, right? Somebody is paying your salary, right? And so somebody is expecting that you will do a good job. And it's also disrespectful to kind of your own path, right? Is that when all of us were first learning about things, right? Somebody excited us about science, somebody excited us about mathematics, and I think it's our duty to do the same for the generations that follow us. And so I feel like if you don't spend time in teaching and you think I'm going to just do this on some kind of an automatic level, then it often happens that you don't pay attention to students who are somewhere in the middle, right? It's very easy to pay attention to students that are doing great, right? Because we are excited that they are doing really well. And the students that are failing are usually, you get some kind of a notification, this student is failing. It's obvious we don't like to have failing students in our classes, so it's easy to pay attention to them as well. But then the students who are maybe at the level of B, right, that might be excited about your topic, but just aren't, where you make the biggest difference, those are the easiest to ruin, right, if you don't pay attention to teaching. And the second thing is that also teaching, as everything else, right, if you don't pay attention to it, it gets harder. So you forget to assign a homework, and then you have to rush it, and then it's hard to grade because you didn't check your numbers, and so on. And so like anything else, right, doing a job poorly doesn't only mean that the job is done poorly, but it also means that you're probably not enjoying doing it. And so I think in academic careers, like compared to some other people who do manual labor or in service industry in restaurants and so on, we have a privilege that our job is much it has more potential, right, to be easy on the backs, right? We're comfortable, we're in air-conditioned rooms and so on, and so it's somehow, if the job is difficult, we have to figure out how to make it go a little bit better, right? It's not really always external that we're struggling. Yeah. So I think I'll stop talking right now, and also say that I really appreciate everybody who invited me to speak, and I wish this was kind of a more interactive environment as well, where we could actually talk about the realities of travel, right, and the realities of coronavirus makes everything more difficult. But
that's true. I mean, definitely once we will be out of this pandemic, we will try to arrange this such sessions. Okay, so that's true that research is a continuous process. You have to go through each part of it. It's not like you will leave the research and do teaching and again you start that. So regarding to same questions, I'm having another question, which is, as a university faculty, which one is important, teaching or research? Why I'm saying that, because there is difference from college. In Pakistan, we got college means the high school here, 2 years, last 2 years are
Hmm.
called college in Pakistan,
I
but
see.
here they call it high school. So as a university faculty, how you see that, and why teaching or research is important in the university?
Yeah. On a personal note, when I was thinking about, having an academic career or even getting my PhD, I didn't even know what it meant to have an academic career. Right? You just want to learn more. That's I think for all of us, that's the case. I always think of research as something that was exciting me more. Right? I did not have a dream of teaching in a high school or college or sitting or even going into a classroom. Right? I thought about developing new things and learning new things and things like that. So on a personal note, I'm more excited by research. Um, the As far as the university that employs you goes, right? Well, that can really depend. Even here in US, right? Even locally, right? Here in Potsdam, we have within 15 miles radius, we have 4 different schools that are all universities, right? In kind of in the broad sense of the word, but we are probably the ones that have the highest research activity among them. And then we have 2 schools that have kind of medium level research activities, which don't grant PhD degrees in all of the cases, right? And so most of their programs end with master's degrees. And then we have a school which is kind of simply oriented toward technical things. So I don't think that they even have master's degrees. They just grant bachelor's degrees. And all of those faculty who teach there, right, they're all university faculty, but obviously different schools require them to teach more if the research output of the university is not very expected, right? And for us at Clarkson, they want us to teach. They give us an ability, right, to teach less. But in return, we have to produce papers and supervise PhD students and apply for research grants. And then if you think about universities that are much better known than Clarkson, like Princeton and Harvard and Caltech, MIT, those universities are even more prioritizing research, right? And so, whereas at Clarkson in mathematics, faculty teach 2 courses per semester, it wouldn't be uncommon for somebody in a similar position to me at MIT, for example, to teach 1 course per semester, or maybe 1 course in the fall and 0 courses in the spring, because the university says all of your priorities should be in research. So in that sense, we all have finite time, right? And if university says you have to teach 2 courses, then you don't have an option, right? You lose immediately. You don't have access to at least 6 hours of your week, right? Plus the preparation and so on. So I think it's for people who are trying to do research, right, that this becomes thing that needs to be actively managed, right? Where you say, okay, let me try to figure out when I am most likely to be productive in terms of research, and when I'm most likely to be productive in terms of teaching, and then try to figure out how to do that. So in that sense, from my personal perspective, it's not that one of them is more important than the other, right? And I think as a mission of teaching and as a mission of research, both are very important, because somebody taught Einstein, right? Somebody taught Cauchy. Somebody taught all the kind of big geniuses, right? That we think of making big advances. Somebody taught them and got them excited of it. That person doesn't get the recognition. Nobody. Maybe at the time somebody was like, okay, that guy who got the Nobel Prize, that was my pupil, right? But we don't remember those people in history very well. But still, if that person wasn't there, we wouldn't have, atomic energy. We wouldn't have anything, right, of that sort. And those people, nobody kind of developed anything in a vacuum. So in that sense, I think the missions are equally as important. But kind of in a day-to-day life, I try to prioritize my energy toward research, because nobody's pushing me as hard to do research as hard as they're pushing me to do teaching. If I don't teach, if I don't show up in the classroom, my department chair is going to get angry emails, right? If a student is banging at my door needing help with homework, right, it's pretty obvious, but nobody is banging at my door for me to produce a new algorithm or a new theorem. So I have to push myself much harder to do research efficiently. So in my priorities, I always first look and say, okay, in what part of my day will I be more productive? Reading papers, reviewing papers, meeting with students who are my PhD students who are doing research with me. Those things are always scheduled first. And then I know that even if I'm sleepy in the afternoon, I can still talk to undergraduates about their homework, or I can still grade, right? Even when my mental capacities are not at the high point, I can do teaching things, and I can do them well enough that they don't suffer in quality, right? I grade equally well in the afternoon, equally correctly in the afternoon and in the morning, right? My lectures are, maybe if it's 7 a.m. and 9 p.m. classes, those are not as high quality as 3 p.m. classes, but between, normal work days, I can do teaching equally as quality with respect to the quality, whereas research I can't. I do know that I have the time in the other day when I'm better at research or not, so I prioritize that.
Great. Yeah, I think I got a question from your answer, which is like, as you said that you were more motivated toward research. So we would like to know that how that started from your high school, from some of them, like where did it start?
I think, just give me a second. I boiled my water for my tea, so I'm going to pour it and then I'm going to continue.
Sure.
I guess I don't know how it started. I mean, I was always curious about things. I didn't really know that mathematics was not something that I considered as a career by itself. Actually my undergraduate degree was in electrical engineering, and even my PhD, even though when you look at my papers, they are papers in applied mathematics, my degree says mechanical engineering on it. So I always thought of as mathematics as a tool, right? As a language, right? To do other things well, right? It's very hard to design something, I think, in modern engineering without having a good foundation in mathematics. So I always thought of as mathematics as a tool, but I was good at it. I wasn't great at it. I don't think. Maybe, and sometimes I was at the top of my class, but usually there was always somebody who did as well as me. I didn't do any kind of international competitions in mathematics, like Olympiads or anything like that. And I'm personally not a very competitive person, so I kind of don't like the competition style research or even problem solving. So that wasn't ever very appealing to me, and I felt that in mathematics, that's what, everybody who did any kind of extracurricular mathematics were always preparing for competitions, and we're always trying to do something of that sort. And I couldn't think as fast. I had to be at peace. I didn't like somebody poking me while I'm working, right, and saying you have only 5 more minutes. So that never appealed to me. But I was curious. I was curious about chemistry, about biology. I was curious about languages. I was curious about mathematics. And that curiosity ended up getting funneled into the mathematics. But I don't think that that if I went with a different career, I think I would be equally as driven, right? If I went into biology, I'm originally from Croatia, and so the education there is it's kind of more naturally, I think, oriented toward natural sciences. But over the course of my life, I have met people who have gone into linguistics, who have gone into information theory in non-mathematical sense, like librarians and stuff like that. And then you learn, oh, those fields are equally as interesting and challenging, and they have their own problems, right? And I feel like, oh, I could have, worked in some other field and be equally as driven and motivated and productive, probably, maybe even better. Maybe I would have ended up being a better chemist than I am a mathematician. But it was all down to curiosity, right? And to say, okay, if I have something that I'm looking at, like, let me poke at it, right? Like, let me try to figure it out on my own, rather than always being either discouraged by the fact that somebody already went 90% of the way, or somebody even went the whole way. Maybe the problem is already solved, but let me try solving it my own way, right? So that was something that I was curious about. And then a lot of it was, I think the what really drove me into kind of technical fields and engineering and mathematics was the computers. Is that with chemistry and with biology, it was much harder for me to imagine how I would make my own lab in my bedroom, right? Like, where would I did have like one of those chemistry kits, and my grandma was a biologist. She was a high school biology teacher, so she would like explain biology to me. But like, my parents did not let me have 15 different animals and try to I couldn't even imagine what I would do with cells, right? Chemistry was out of the question whenever fire comes up, or dangerous chemicals, right, or explosives. So I feel like the computer was the tool that I could experiment with safely, even though, again, my parents didn't like me spending too much time on the computer, but at least I wasn't trying to blow the house up or set anything on fire, so they let that go. And so that became programming and exploring how to write programs to draw fractals and things like that was where I felt like, okay, I can do serious, quote unquote, serious stuff. The more stuff that you learn than you learn in school, and that's kind of how it all went. That was late high school probably, and early on in college, and then from that point on, you already start interacting with people who are professional scientists, right? You're in universities, and so from that on, it was pretty clear how to go forward. Yeah.
All right. Very interesting. Okay, so my next question would be, how you define an independent researcher?
How do you what?
How do you define an independent researcher, like a person who can do research, and what qualities do you find in him?
Yeah, well, that's a very hard question. I think from the perspective of just kind of a job in the US, to be independent means that that you have some degree of choice of what topic to work on. It's never complete freedom, right? Because somebody is paying your salary, right? I can't just decide tomorrow, oh, I want to do high energy physics, even though there's no law prohibiting me doing that, right? I will not get money. I don't have a background. I don't, I'm in the Department of Mathematics. So you still have some constraints, but I can choose to work on this differential equation or that differential equation, or work in topology, or switch to statistics, right? I can apply for my own research grants, right? Which makes you independent in some sense from anybody else, which is different than when you are a postdoc or a PhD graduate student, right? Where your advisor or your supervisor is the one who is determining what, at least, narrow field of topics you're going to be working on. You might still have some freedom, right? But usually is if you can get your own independent money for research, that makes you independent, right? Even if you're somehow rich, right, and your family is very rich, and so you don't have to work for a job, then you're an independent researcher just because you can research things without anybody complaining. But in terms of kind of what makes a good quality, I think, like I said, I talked about curiosity. I think the kind of having the idea of saying, I'm willing to step into fields that I don't know much about, and into new topics, right, and kind of expose yourself, expose your lack of knowledge, and being patient with yourself and saying, okay, yeah, I don't know this stuff, right? It might take me 6 months to learn. It might take me 2 years to learn, right? But I'm confident enough that I know how to learn new things on my own, right? And that there is a path, right? And not to be too afraid of doing that. Of course, it's always safer to do things that you know, right? But being willing to say, I want to do things I don't know, is, I think, an important quality. There is a lot of, I think, there is a lot of research where people just kind of, they learn how to do one thing well, right? And then they repeat that for the rest of their life, which you can have a successful career in doing that, right? Like, you know, how you have a method for solving differential equations, for example, a particular differential equation, and then you apply it to very different problems over and over again, and you can have a successful academic career, probably doing one thing well. But you know, how long can that sustain your curiosity, right? Like, maybe you can do that for 5 years, but a new thing that you develop, after 5 years it's not new anymore, right? And 20 years from now, if you're still doing that thing, that's not research anymore, that's now technology, right? And it could be a very fruitful career, but it's not kind of a novel research in the same way that you started out doing. And people do change careers and all of that, right? That's a different style. But I think being willing to do new things is important. And the second thing that is important is actually being organized in doing that. From my perspective, I'm not next Feynman or next Marie Curie or anybody like that, right? Like, I'm not a genius that I can just wake up one day and have a whole theory in my head. The thing that I do, right, it's bit by bit, and so I have to be organized in the sense that I have to have a good documentation of my own thoughts, right, of my papers, of my numerical codes, of my references, so that the energy is not wasted on relearning the things that I already have learned, right, or trying to find things that maybe don't exist there, but so that I know, okay, this range of things has been done, right, and this is new. So that requires. And I think that's a hard thing to do, because it's easy to say when you're a PhD student, when you read papers, right? And you read papers by very, very successful people who are, have awards after their names, right? And they work at Stanford and UCLA and, all these high-powered universities. It's very easy to say, okay, I'm reading their papers and this is amazing, right? But once you're kind of at my career stage, you see some people who are at the same stage of career as you, but are doing better than you, right? Like, they discovered something that you haven't, right? Or they have won an award, or they have more published papers, and they maybe work at better universities. It is emotionally complicated to say, okay, I'm going to read their papers with the same amount of curiosity that I read the papers of much more senior scientists, right? From 50s. But if you don't do that, then you stop learning about where your field is. And I think that's a thing that also needs to be remembered, kind of as you develop your career, is that there needs to be some level of humility and say, I'm not the smartest person in the world, right? And there are people who are doing good stuff, and I should be equally as curious about their stuff as I am about some other stuff. Otherwise, you end up becoming kind of an island, right? And say, I might be doing really well in my department and my colleagues respect me, but research is, I think, about contributing to a broader scientific development that is kind of worldwide endeavor. And if you're only recognized in your own little circle of people, right? Like here in Potsdam, it's very easy to be isolated. Many of you don't know, but we are basically 2.5 hours from the nearest city in any direction. And so it's very easy to say, okay, I'm doing well here. I'm happy. I have my garden, right? My kids are getting big, right? And that's perfectly fine. But if you do want to if you aspire to kind of the research mission, I think you have to be able to put yourself there and take a risk, right? And to say, okay, these are my ideas. Go to conferences, try to publish it in big journals, and say, these are my ideas, and I'm willing to be critiqued, right? If they're bad ideas, I hope somebody will tell me. I would rather somebody tell me the first time I present something, this is bad, so I can think about, is it really bad, or is it that person just doesn't understand, rather than let me work on this for 5 years and then discover it's bad, right? Because then it's 5 years wasted versus 5 months wasted.
Okay, all right. Yep. So now my question will be more toward the particular teaching and research.
Mm-hmm.
So teaching is considered as a difficult task when you have to grade the assignments, quizzes, and exams. What are the best ways to reduce these efforts and get more time for research?
Well, one of it is preparation, but I don't actually think I'm a very good role model in that, because teaching does take up a lot of my time. It's just that I try to push my days. When my kid goes to bed and my wife goes to bed, I go back in front of a computer. So in terms of how to reduce things, I think keeping track of what worked and what doesn't work is important. I don't know how it is for faculty in your university or more broadly in Pakistan, but here we do usually teach similar courses over and over, right? So I have taught, for example, undergraduate differential equations now for 4 or 5 semesters, right? And so that first semester, my teaching time spent on that course was probably twice as much than it was in the last semester, because I didn't have the assignments developed, right? I didn't know what to expect, what is going to be difficult for students, where I'm going to spend more time, where I'm going to spend less time. But you keep track, right? And then next year, okay, like an example of there, right? Sometimes you have to solve a very big system of linear equations, right? And it's a 5x5 system, and you're asking your students to do this by hand, and then you have to grade it, right? And then you spend, additional week, right, grading 80 students' assignments that are all very similar, but very slightly, halfway between second page there is a typo, and you have to find it, right? And then you ask yourself, like, is this what I really want to teach, right? Is this is the knowledge of copying by hand, line by line of matrices without making a single typo the thing that needs to be learned in this class, or am I trying to teach something that is a more fundamental concept, right? And so you kind of you keep track of what's working, right? But you reevaluate and say, okay, these things are difficult, and they shouldn't be, right? Like, busy work and so on are things that people are good or bad at, right? And we can pressure students to do that. But if the mission of my class is to teach people about differential equations, perhaps I don't have to assign the most difficult function in there to take a second derivative off, or to take a second integral off. I can teach the same concept with something that is slightly simpler, where the students can actually focus on the thing that is important rather than focusing on the busy work. Because in a lot of cases, right, the time spent grading and so on it's very easy to see that some student understands the concept or doesn't understand the concept. It's like figuring out of 32 points, whether the student has lost 1 point or 2 points or 2.5 points or 2.25 points. And I think at some point you just realize that some things are there in our teaching that are happening by inertia, right? Why do we grade things in terms of percentages and points when nobody really everybody, probably university in Pakistan, similar to here, people require you to have a final grade that is on some scale, right? Between 0 and 20, between 0 and 5, between F and A, right? But nobody says on your third homework, the second problem has to have 7 points, or it has to be a yes/no question, right? That part we can decide our own selves. And even people who are teaching assistants, right? If you're giving quizzes and so on, maybe you don't have a full control over a final exam, but you do have some control about how to give intermediate assignments. And then you say, well, am I doing this thing just because that's how it was done to me when I was in school? Or am I doing things because I actually think this is a way to save my own time, but still not to compromise the learning? And there is, especially in mathematics and in physics, math and physics are, I think, two fields that are leaders in reevaluating how we do assessment of students and how we spend our time in classrooms, so that the time is spent meaningfully rather than spending time in a way that is there just because it's inertia, right? If you have a set of lecture notes and your entire 1-hour lecture is spent from you reading those lecture notes to students are not learning. They could just be reading those lecture notes themselves, right? which they will do. If they're studying, they're going to do that same thing over and over 3 times after you taught. So why does it matter that you read that for the first time? You are bored. You are not excited about that, right? So it might be better to actually say, okay, read this ahead of time, and then come to class and we can work on some problems together where I can actually show you how to do certain things, right? And then when you're testing things, right? If it took me in a class to solve something with a student 20 minutes, right? And then I can't ask for that problem to be solved in 3 minutes on an exam, right? Then you have a sense of how it is to be a student again, and where the students are struggling with, and what is where they are, which helps you again manage your own time between assigning a 5x5 linear system problem, right? Or say assigning 2 smaller problems that are easier to grade, but maybe test 2 different independent parts. Maybe, I'm taking an example here. I'm not really sure what people listening, what their expertise is, right? But saying, I'm going to try to teach Gaussian elimination, right, or row reduction. Maybe I break things down into interpret what form of the matrices means that I have infinity of solutions, what form of matrices means I have no solutions when I have a unique solution. That could be a separate problem from, let's just test whether you know how to do operations, right? And then it's easier to grade, right? And then you're also more certain, are students struggling with the just arithmetic, right? Or are they studying with struggling with the conceptual things? So there are ways to think about these things, but I mean, inertia is the devil, right? Like, you take somebody else's class over, they give you their homeworks, right? And you don't question them, and then you realize 3 years in, this is just a lot of busy work, but what can I do? I think that's the part where we have to say, I have some agency, right? I have an advanced degree in this field. I think I know better, right? Let me try this for one homework. If it doesn't work, I'll do something else, right? So similarly with research, right? Similarly as with research, you experiment, you try something new. If it works, you make a note of it and do it again, right? If it doesn't work, you back off, right? And you say, this didn't work because it doesn't fit with my style of teaching, it doesn't fit with student expectations or something else, and so maybe it's not worth my time. Yeah.
All right. Yeah, I think we are almost half of the time, more than half of the time, so I'll go quickly to questions. So my next question will be, what are the possible ways to create direct link between your research and your classroom?
So that is hard for me, especially for undergraduates, just because my research is in differential equations, but the things that I actually spend time worrying on are usually things that go between different courses, and are usually at the level where undergraduates end here rather than when they start. So it is very hard for me to say, go into a sophomore class and say, I'm going to teach students about something about my research. That almost never happens. But I think we as researchers, right, I don't have to bring my latest paper into my classroom to make it interesting. I go to conferences, right? I read journal articles, I talk to other researchers, people come and give seminars here. And so we can connect some of those things that we learn about that people don't think about, right, when they first enter the university classrooms. So, for example, when we teach differential equations, here we have a lot of students who are going into mechanical engineering and aerospace engineering. They hear words like resonance, and they hear words about like oscillations, and they are never properly explained to them because at that level, they're still too early in their career to start serious engineering, but these are the things that people dream about, right? People become civil engineers to make bridges that don't fall down. People become aerospace engineers to make planes that go faster and more efficiently, and so on. Mechanical engineers for various reasons, right? And so they do have some interest. And then so some of these words that are kind of part of our everyday language, but are not very precise, I try to make them precise mathematically and try to show them how to think about these things from a quantitative perspective, which lay people from the streets don't have. So during the coronavirus, this is maybe particular to kind of colloquial English language. But those of you who kind of read U.S. News, and probably British as well, know that it has been very fashionable to say that when something is fast recently, to say that it is exponential, right? Oh, this has been, we have seen an exponential growth from last week to this week. What does that mean, right? Like it means nothing. People in journalism and writers, they just want to say very fast, and when they want to make it sound very flashy, so they say exponential. But then when the coronavirus started, right, at the beginning of all of the infections, right, there was an actual exponential growth, right? And so, for example, last fall when I was teaching the differential equations class, we actually talked about what it means to have an exponential growth that comes from differential equations, right? And even though that's not my research, that was an opportunity to make the topic exciting to students because you're connecting it to real world, and do so in a way that it actually shows them the value of what they're learning in the classroom, right? They could sit on a bus or on a train and somebody could explain this to them, but they're not, right? They're taking this class with you because they feel I think every student wants at the end of the class to say, I have learned new things and I can do things that I didn't know how to do 3 months ago, right? And so even if solving second-order differential equations by characteristic equations is not something that is either related to my research or related to real life, if I do introduce some of these connections with everyday life or with my research when it happens every 2 weeks, right? It's enough to keep the interest level going. You build trust with your students that you are a real scientist, that you know what you're talking about, and then they're willing to believe you when you say, this thing is actually important, it's going to show up in your classes next year. They're willing to say, okay, this guy knows what he's talking about. Rather than if you never really show them how my line of thinking is different from somebody who has never taken differential equations, then why would they care? They didn't learn anything new. They were just tortured for 3 months with exams, right? So yeah, in that way, right? I don't insist. And also, this I think is I also have had to learn that people say connect your research to your teaching. I have to learn not to try too hard, in my sense, because I tried it and then it didn't work. Then you go too deep, and people lose interest again. So you have to kind of know when people say connect to your research, they usually mean just go a level deeper than what the textbook says, and that's typically enough. You have to just show the first step. You don't have to take them the full rabbit hole of science to actually do that connection. Yeah.
Cool. So my next question is regarding to the advising the students. We call it here supervisor, and in US we call it advisor. How US professors work with PhDs to get their PhDs done in 5 years, even they start after undergrad.
Yeah.
So what are some important points to be successful advisor or supervisor?
I don't know. I'm still trying to figure that out. Like with everything else, you can sense a theme here of what I'm doing. I'm trying new things and keeping track of whether they have worked or whether they have not worked. I think one thing that we should not be doing is to constrain the students so much that their work becomes a boring chore, right? I think it is very hard to get a disinterested student across a finish line, right? A student who feels that they, after 3 years spent in their PhD program, should get a PhD degree in 2 years, right? But and so who is not willing to give up on their own, right? But now they have lost interest in the field, and you have to figure out how to do that for them. That's I think the hardest position to be in, right? So the first thing is to make sure that the student remains engaged and curious no matter what, right? Like that also means if you feel like student is burnt out, disinterested, right, is not producing new research and so on, just adding pressure and forcing somebody to do something can be very counterproductive. For some students, it actually can be very productive because maybe they feel like there is no urgency to progress, right? With some students, they feel like they might think that everything is going fine, so you have to increase the urgency. But I don't think that there is one easy way to say this is how you do it. I think it's very, very important to have a personal connection to your students. That doesn't mean that you have to have students over for dinner or be Facebook friends with them or whatever, right? But you have to know this student has, a kid at home. If I ask them to work tonight until 7 p.m., that's unreasonable, right? I will choose my family over research, and I will expect all of my students to choose their kids over work with me, right? And so it is unreasonable to put pressure on somebody who is trying to raise a family in that way, right? This student might have had a parent pass away, right? We have a lot of, like you and like me as well, we are both international students here in US. We have families, you in Pakistan, me in Croatia, right? My advisor was very sensitive to that fact. So if I'm worried about something happening at home, give students some time to be worried about that, right? Like, don't try to say this is the most important thing in the world, because it is not, right? We all know it is not, right? We can pretend, but I have had periods of my time where research was not working, and my advisor was kind enough to say, okay, I will take my foot off the gas, right, and let you figure that out. So I think that is important in treating people like they're human beings rather than trying to have them be robots, right? That doesn't work. I think in general, maybe it works for some universities where it is very, very high pressure. You have a high number of good candidates, and so you can just burn 3 people to get the 4th one that is a genius that you don't have to work with so far. But I don't think those people are good human beings that do that to their students, and I also don't think it's efficient, right? So that's kind of from a human level. That's one thing. But other than that, I think teaching students that trying to put yourself in the shoes that where you have students who are just coming out of undergraduate degree, who don't know how to look up papers, right? Who don't know how to write a paper, who don't know how to start a manuscript. Knowing and that even some of these basic things you have to teach over and over, because I think with industry, right, you kind of, when you become more senior in industry, your people who work with you become more senior as well. With universities, you're always dealing with people who are just fresh out of undergraduate, right, or maybe coming back to academia. And so being structured about that, and then showing them the interesting things and hope it works, right?
Yeah. All right. That was very interesting to know. And the next question I have regarding interdisciplinary research. How important is interdisciplinary research, and how it can be started if you have no funding? Because normally people think that if you have funded project, then you can involve a lot of different people from other departments. But what do you think about that?
I think for mathematics and statistics, we are lucky in the sense that everybody wants us and everybody needs us to a certain degree. So if you not everybody, but a lot of other fields are willing to work with mathematicians, right, and with statisticians. So we are the ones who get invited, and we are also cheap, right? If I want to spend a certain portion of my time working on a new project from chemistry, right, that's not very hard. If a chemist wants to collaborate with somebody, they usually need to buy equipment and so on and set up a portion of their lab to do that, and so that's harder for them. So I think that's not very hard to do. I think what is hard is usually when you collaborate, you don't operate at the peak level of your discipline, right? You're trying to, it's kind of more like a technology transfer, right? Where you're trying to get a certain algorithm or certain idea for involved with a different discipline, right? And you are somewhere, like if you think about the scale between something is old, like addition, right, to something that is very, very new and high powered, usually somewhere in the middle is where the collaboration happens. And so I think there is some danger to say if all I'm doing is collaborative work, then I'm kind of like a janitor for everybody else. I teach them how to do statistics. I teach them how to do differential equations. I teach them how to do this, but I'm actually not developing myself or my discipline forward. And so, it's fine, right? Like that, for a long while, and I still, to a certain degree, maybe think that that's actually my role in research, is to actually help people understand some things in mathematics that they wouldn't otherwise, and apply to their discipline, right? So that can be, but I think it has to be a conscious decision, right? Where you say, I'm not fooling myself when my research will not generate a Fields Medal, or I will not generate a Nobel Prize, because my role is not to push a discipline as far as it can go, but to connect two disciplines, right? And so it can be a very, very fruitful and satisfying career to do that. Yeah, in terms of funding, I don't think that matters, and it actually, usually the interdisciplinary research is formed before the money comes. Once you have the money, then it's already decided what that money has to be spent on. So you have to start moneyless, right? You have to start collaborating before you actually have money to form an interdisciplinary collaboration. And in terms of importance, I don't know. It can be important. It doesn't have to be important, right? I think that's a personal choice. Like that's what we were talking about very early on. Being an independent researcher, that's a part where you can choose. I want to be mathematician and only a mathematician, or a statistician and only a statistician, or I want to be somebody who, like your advisor, right, is an excellent example, Shimona Mondal, right? She collaborated with biology, with chemistry, with materials engineering, with everybody, right? With health departments and so on. And so she's an excellent person who to demonstrate that you can have a very, very successful career in basically helping other fields understand the new developments in statistics. But this likely means that she will never be, on a Wikipedia page written as one of the mothers of the modern statistics, right? And so if you're okay with that, then you know how to spend your energy as well, what you want to do. And I think for me, like I said, I was curious about very different disciplines growing up. And so for me, it's more interesting to figure out, can something in biology be solved using mathematics, rather than say, I want to prove a theorem that nobody else except 3 other people and will read for the next 30 years. Maybe it was very difficult, but maybe it doesn't get I don't get so much out of it. Yeah. So yeah, it's kind of a personal decision. Yeah.
Makes sense. Okay, so next question is, what techniques do you personally use to maximize your time, both research and teaching, and to make it productive?
Let's see. So I maintain a schedule, and on Google Calendar, you block off times to do this and do that, even if that time is with nobody else. So if you need to write a proposal, if you need to write a paper, then you enter the time in your calendar for these 2 hours I'm going to be writing, right? I'm not going to do anything else. On my computer, I have a whole bunch of things that prevent distractions. I am not logged into Facebook or Twitter, and I have a program that says that blocks all the pages for the next 8 hours that are news related, that are it's very easy to find these things as add-ons to the browser and so on. Sometimes it can be hard, I think, to communicate this with other people, but like my wife knows that different people have different types of job responsibilities, and some people might have some time during the day where they don't have to do anything, right? They're waiting for something or whatever, and so in that time they check their Facebooks or whatever. I feel like my time is precious during the day, and I don't have that gap time, because if I can spend now half an hour reading the news, I could be answering an email to my department chair. Like cognitively, they're not very hard tasks, one or the other, right? But one of them has to be done, the other one does not have to be done. And so I read my news in the evenings when I'm tired, or in the morning when I'm making breakfast. But I try actively not to do that. And I fail every day. Every day I fail, and every day I try to do better next day. So I think that is important. What is also important, I think, and doesn't get talked a lot about is mental health. It is. I think it's when we do feel like we are burning out and when we have worked too much, the attention drops, and you start to feel bad about your work. You start to feel lonely and so on. And those are the times where we are most likely to to engage in the stuff that is not a high quality time spent, right? Whether it is scrolling on Facebook, right? Whether it is reading the news that that is not news, that just news entertainment, right? Oh, let me see what this senator in Texas did. Like, okay, right? It passes your time, and so I think trying to make sure that if you feel like you're lonely, you recognize you're lonely, and then you go out and spend time with your friends or call your family or do something that is actually going to help that loneliness, not just mask it, right? If I feel that I'm tired, not to spend time in the middle of the night watching TV, because yes, I enjoy myself watching TV, but next morning there's going to be even more pain, right? And so a lot of that stuff comes from just actually paying attention to your own thoughts, right? And saying, okay, these are my bad patterns, right? This is what I do when I'm sad. This is what I do when I'm tired. This is what I'm doing when I'm upset, right? Maybe it's not the best idea to like eat a whole box of cookies before sleep, right? Because next morning my mind will be cloudy, or worse, right? People who drink, right, to actually drink before going to sleep or anything of that sort, right? Because next morning I'm going to feel terrible, and it's just going to so trying to maintain kind of your mental hygiene, your personal hygiene in terms of eating well and sleeping and getting, you don't have to go to gym every day, right? But you should walk around, right? And you should do stuff away from the computer, and then saying, okay, that's also a part of my day, right? I need to eat healthy in the morning, otherwise I feel bad in the morning. That means you have to wake up 30 minutes earlier to make a good breakfast, right? And so being conscious of all of those patterns, you treat this as a career, right? Not as a boot camp. Maybe the first semester in graduate school is, do everything just to survive. But at some point you realize, okay, I have a routine right now. I know what's going to happen. I don't have to be in a panic mode. At which point, take some time and say, okay, this is for the next 3 years, I'm going to be in graduate school, or for me, for the next 5 years, I'm going to be on the tenure track where there's a big review coming afterwards, right? This is how I'm going to organize myself consciously to be successful, rather than just hoping that what worked in high school to get a good grades is going to work well when you're 35 and trying to publish a research paper, right? It will not. And so yeah. That's kind of the biggest thing that I've learned probably over the last 3 or 4 years. I wasn't good at it at all in grad school.
Cool.
I probably would have finished 2 years sooner if I listened to my own advice.
Wow. Okay, so this would be my last question, which is more toward Pakistani universities. So Pakistani universities are mostly focused on teaching, except a couple of fields, not for innovative research. What do you say to Pakistani university teachers or students who are listening in this session to order to motivate them?
I think it is similar situation for universities back home where I'm in Croatia, and it's actually more similar than you think. Also with universities in the United States, most universities in the United States are oriented toward teaching, and only those we hear about very high-profile universities, like I said, Stanford, for instance, and so on. But you can probably count them on your two hands, right? And then you run out. And yet, in every region of any state, there is probably 10 or 15 universities that are just teaching universities, right? So I don't really have kind of a great advice there, but try to. I think it's very easy to try to do the most grand thing possible. And then fail and then be very discouraged. Rather, try to do some things that are within your reach and build the momentum, right? Okay, maybe I understand I don't have 40 hours per week for my research. Maybe I just have 3 or 4 hours. That doesn't mean that I should spend those 3 and 4 hours wishing I was doing Nobel Prize winning research. but let me try to do a delta, right, where I can actually feel good about my own contribution. I can develop one result well enough to get published, and then it grows, right? Then it grows. If the only thing that you're working with is shooting too high and then getting discouraged because you don't have time to do that, then you don't go anywhere. So you have to do it incrementally. Kind of like if you want to go and become and get healthy and have muscles, right? You don't start with Olympic weight level of weightlifting, right? You start with small weights and then you slowly build up. And you have to trust that over the next 2 or 3 years, you're going to get to where you want to be. But trying to lift, 300 kilos and not succeeding, right, is no way to do weightlifting. So it's the same thing with research, right? Is to start small and build on it, right? The second thing I think is important is to actually stay connected with other people who want to do the same thing. Find a collaborator, right, at either your department or a different university who is in a similar position with you, and to say, okay, the two of us are going to pull and push each other rather than hoping that this is going to happen, alone, right? It's a route to becoming crazy, right? Is to say, I'm just going to be in my own room and hopefully good things are happening, right? And not talk to anybody about this. It's much better to have a friend and get together for one afternoon during the week and say, let's do something together. Let's develop an interesting project for us and see this grow over time. I think is a way to go.
Great. All right. I think we are good now. Before ending session, I would like to thank again Professor Marko for providing us time, and I would like to thank to our SMI University Teacher Association who has arranged this nice session and gave us opportunity to talk on this topic.
Thank you, Vijay, and thanks everybody for joining in. It was an interesting conversation. Thank you.
Thank you. Yeah.